So in this video we are going to learn how to calculate the perpendicular distance of a point from a line. Suppose we have a straight line and the equation is given, it is in standard form as you can see, and there's another point which is not on the line. This point is not on the line, it should be on this side or other side, we don't care. So we don't really need that. We need to find the perpendicular distance. That means if you draw a perpendicular line, right, perpendicular line, okay, then you have this distance. You want this distance. It's like the shortest distance. So let me call this D. Now we need to find this length. Now in this case we are going to use parametric form, right? So if you are not going to use parametric form, this is what you can do. Is that now since this is a perpendicular line here, let me put Q there, right? It's a perpendicular line here. Okay, so we can find the gradient of this line, because the gradient of this line must be perpendicular to the gradient of this line. So we have that relationship here. The lines are perpendicular, so the gradient have this relationship. Using that relationship, you can find the gradient of this line. Right? Then you have this point here. So using that, you can find the equation of that line, PQ. Then using these two lines, you can calculate the point of intersection, right? Point of intersection, and solve for that and find the coordinates of Q. Let's say the coordinates of Q are x bar and y bar. These are the coordinates. Now we have one point and another point. You have learned how to calculate the distance between 2 points in the Cartesian plane. Remember, then the distance should be square root of alpha minus x bar squared plus beta minus y bar squared. This should be the distance between 2 points. That's one way to go for it. But there's an easier way. Especially when it comes to symbolic problems, we are going to use parametric form. Okay. So let's see how to get this done. So using parametric form, now we know. So the gradient of the line PQ. So gradient of the line PQ must be minus 1 divided by gradient of this line. So gradient of this line is minus A over B. So it would come up to be B divided by A. This would be the gradient. Okay. So now I can represent any point on this line PQ. Any point on this line PQ parametrically how? Right. So let's suppose this x bar is the point. X bar is the point that we need. Okay. Right. So Q, I made a small change here. Let me put the point Q here. And another point P1, this is a movable point on this line PQ. Right? We can write this parametrically how? Y minus alpha, right? Y minus alpha must be equal to B divided by A gradient x minus beta. Now let's write it in parametric form. So Y minus alpha divided by B equals x minus beta divided by A must be equal to T, where T is a parameter. Right? You can just say T is a real number. Now using this, we can write y should be equal to alpha plus bt, and x should be equal to beta plus at. Any point on this line. So we can represent this Q point like this. The point Q, the coordinate, can also be represented like this. Right. So they will have a certain thing. Since x bar y bar, you can write x bar y bar like this. Okay, alpha plus bt and x bar beta plus at, because this is any point on this line. Right. Since x bar y bar, this point is on the line, it should satisfy the equation. So let's write down the equation. So a times x beta plus at, then b times did I make a mistake? Sorry about it. This should be alpha, this should be beta alpha, sorry about it. So beta alpha. I should have changed these two instead, but that's okay. Say alpha beta plus bt plus bt plus c equals c. from this equation we can find a value for t. How do you find a value for t? Let me expand this one. Then a alpha plus a square t, b beta plus b square t plus c equals 0. Then we can factorize this one. Then t equals, so t times a square plus b square must be equal to minus a alpha plus b beta plus c. So t is therefore equal to minus a alpha plus b beta plus c divided by a square plus b square. This is the t parameter. That means when you change t, this line moves. When you change t, this line moves. But what should be the value of t if this movable point is at q? Right? So q වල තියෙන නම් මේ movable point එක, that means x bar y bar වෙන්න නම් what should be the value of t? The value of t should be this. මේ value එකට ආවම අනිවාර්යයෙන් මේ point එක මෙතන තියෙනවා. හරිද? ඔන්න අපි t හොයාගත්තා. මේ t මෙතෙන්ට substitute කරාම we get y bar and x bar. හරි. But that is not what we need. We need the perpendicular distance. So I'm going to erase this one and continue from here. Right. So what we need is a perpendicular distance. How do you get the perpendicular distance? D should be square root of x bar minus alpha. Make it's up to you. Y bar minus beta square. Right. So what is x bar? X bar can be represented parametrically. There should be alpha plus a t minus alpha, right? Method ma make replace kara. Then beta plus dt minus beta square. You can see that alpha goes off and beta cancels out, and we get square root of a square t square plus b square t square. So let me take out t. Then I get t square root of a square plus b square. Okay. Now here, there's one thing you should know. Now this d here, d must be positive quantity. D is a length. D cannot be negative. The square root will definitely be positive because here we have a square and b square and addition. It's definitely positive. So t must be positive. Therefore, we put modulus there. අනිවාර්ය modulus එක දාන්න ඕනේ. So what was the value for t? Then if I substitute value for t, I get minus a alpha plus b beta plus c divided by a squared b squared, and you have to multiply this by, we have this modulus sign. We don't really have to put the modulus sign for this one because this is always positive. And when I'm positive in our modulus sign, then we have a squared plus b squared. Cancel out, then finally we get the perpendicular distance minus, sorry, you don't have to put minus there. Okay. So a alpha plus b beta plus c divided by a square plus b square. Please memorize this formula. Make hard lazy memorize කරන්න. මේ memorize කරන්න හේතුව part A questions වලට මේවා කෙලින්ම ඇවිල්ලා තියෙනවා directly. Right. So find the perpendicular distance of point 1,4 to the line this. Now we have to make sure that this point is not on this line. So first substitute and see. 2 times 1, that is 2. 2 plus 4 is 6. 6 minus 3 is 3. So 3 is not equal to 0. Therefore, this point is not on the line. So you have to make sure that first. If it is on the line, then you have to find the distance. This is 0. Right. So all you have to do is just do a sketch. Make a full sketch and the line should be 2x plus y minus 3 equals 0. So put d here. Therefore, d is a alpha plus b beta plus c divided by a squared plus b squared. Right. So what is a? A is 2 in this case. What is alpha? 1. Then here the coefficient is 1, right? Plus 1. And y in this case is 4. Plus c is minus 3. So just put minus 3. Divided by square root 2 squared plus 1 squared. මෙතන මේ minus එකම දාන්න යන්න එපා. කිසිම විදිහකට නෙගටිව් එකක් මෙතනට එන්නේ නැහැ. හොඳ මතක තියාගන්න. So d is therefore 2 plus 4 is 6. 6 minus 3 is 3. හරිද? මෙතෙන්ට apply කරලා එන එකම තමයි එන්නේ. We get a negative sign, then you get the positive, right? It's the absolute value of that. This should be root 5. So what is the answer? Answer is 3 over root 5. So we don't leave it like this. We rationalize the denominator, so we can write 3 root 5 divided by 5 units. This is the answer. It's very easy. Right. So look at this example. Find the length of the sides of ABCD rectangle. Now ABCD is a rectangle. First you have to find the lengths of the sides and its area. Right. So if you find the lengths of the sides, then you can find the area right away. So that's easy. Now look at this problem. ABAD, the line of the equation of AB and AD are given, and a point is given. Right. Point is given. Okay. Now you can see here that this CB side is perpendicular to AB because this is a rectangle, and also CD side is perpendicular to this line. So we can write CB is perpendicular to AB. Therefore, we can determine the length right away. So CB length, let's call it distance CB. Right. Then what do we need to do? Write this 2, then plus 4 minus 2. Write this away. Make a xy meme space there. Right. Then square root 2 squared plus 4 squared. Make multiple. Then the required point is 2, 4. Put 2 and 4. Then what do we get? Here 4, this is 16. 16 plus 4 is 20. 20 minus 2 is 18. So 18 and 18 divided by, this is 4 plus 16 is that is 20 root 20. Root 20 4 root 5. Sorry, 2 root 5. 2 root 5. So we get 9 over root 5. So I'm going to rationalize the denominator and write this. Similarly, I can find CD. So CD is perpendicular to AD. In the DCD make a විදිහටම ලියා ගන්න minus 4 x එක replace කරන්න with bracket 2 bracket minus 4 divided by square root of minus 4 squared plus 2 squared. So minus 4 squared can plus 4. So what do we get? Now replace 2 comma 4. So 2 4. What do I get? This is minus 8, then plus 8. So these two cancels out, and we get minus 4. Modulus of absolute value of minus 4 is just 4 divided by, this is 16. 16 plus 4 is 20. So 2 root 5. So you get 2 over root 5. So 2 root 5 divided by 5. Okay. Therefore, the area, now finally we can find the area. Area of A, B, C, D is the product of these two, 9 root 5 divided by 5 into 2 root 5 divided by 5. Okay, this is 18 divided by 25 into 5. So you get 18 divided by 5. Units square. This should be units. This should also be units. Length units. Okay. So that's it. It's very easy to do. Okay. In the next video, we'll learn how to obtain the distance between two parallel lines. Now we saw how to obtain the distance of a point from a line. Let's see, when we have two parallel lines, we need to know what is the distance, right? The perpendicular distance between two parallel lines. So in the next video, we'll do that.